Hey everybody, today we are going to solve another daily LeetCode challenge, problem 63, unique paths 2 on May 20th, 2022. So the problem is we are given an m by n matrix and the matrix is a binary one and the cells has value of 0, that means those cells are passable. Otherwise, if the cell is 1, that means there is a wall there and we cannot pass through that specific cell. And we have a robot starting at index 0, 0. And the task is to find number of different ways that this robot can actually reach to the bottom right corner of index m-1 and n-1 by having only two valid directions. We can either go to the right or to the down. So we have 0, 1 direction and 1, 0 direction. So this is not a 4 or 8 directional problem. In order to solve this problem, this is a very good example of using dynamic programming here. So consider, let's say we want to find for a random cell, we want to find how many different ways we can go from this cell to our target. So we don't know where the target is. But let's say in the previous iterations, we already know that there are x different ways of going to the target from the bottom cell, and there are y different ways from the right cell to the target. So let's say it is computed already. And we know the only valid moves in this problem is either to go down or to go right. And we know if we go to the right, so this is considered a different way, a set of different ways. And if we go down, it would be specifically a set of unique ways. So we can conclude that the total number of different unique paths we can reach to the target from the current cell is x plus y. So we can simply add up these two values to find the number of different ways. So for that, having that said, we can we can know that if we are in the right or bottom row, so the right column or the bottom row, there is only one valid path to the target, so all of them would be 1, since we know that if we end up in either of these cells, we cannot go to the left or we cannot go to the up. So if we end up in this cell, we should always go to the right, or from this column, we should always go to down. So the number of different ways for these, it is already computed. And by having that, we should only just consider the cells that are walls. Other than that, we can simply just add up the x plus y for the right and bottom cell, and eventually fill up our matrix and return the value of the 0, 0 as the answer of the question, the number of different ways we can reach to the bottom right corner. So for that, let's first of all, so this is the obstacle grid. For simplicity, I'm going to use grid equal obstacle grid. It's shorter, and we have our m and n, the length of the grid and the length of grid 0. Now we want to define the number of different ways as a ways matrix equals initially all of them are 0 times n for in range m. But it is possible that m and n are equal 1. But as we discussed, we want, in order to build our 2D matrix, let's say consider m equal, either of these has a one-dimensional matrix, all in a single row or all in a single column. So we consider this as an edge case so that we don't compute that in our different ways. So if we have a 1D matrix, if any of the cells in that row is blocked, is 1, so the number of different ways would be 0. So we don't consider them at all. So for that, before starting the computation, I say if m less than 2 or n less than 2. So first check if any of those cells are 1 or are wall. So if, let's say for each row, so for row in grid, any of them are 1, and for each cell in each row separately as well, if any of each cell for cell in row, so we are first iterating through each cell in a row, and for each row in a grid, if we find any of those cells as 1, so we should simply just return 0. That means that there is no valid path to the target. Otherwise, we can just return 1. So that means there is only one way, going all to the right or going all to down. Okay, but otherwise, this is a 2D matrix, and we would compute our own way. So initially, we should initialize the ways. For the right corner, so bottom right corner, the ways is 1. And then, as we discussed, now we have this matrix ways. We should fill all this bottom row or the rightmost column all ones, except if we find any obstacle in that path. So after that, it should be 0. So here, for example, we are just filling 1, 1 if there is any obstacle. So after that, it will be 0. So that means if we end up in any of those cells, we cannot reach to the destination because we cannot move upwards. Otherwise, we just check the right cell and the current cell. So for that, I'm gonna do it in a for loop. In range, we are, let's say, we first fill the bottom cell. So the indexes in that cell would be, the first index would be always -1, and then I. We are iterating I from the right to the left in range n-2, -1, -1. So we are iterating backwards. We are starting from n-2, and then we already filled m-1 and n-1 as 1, and then we are iterating from right to 0. So we should first check if the grid of the current cell, the -1 and I, if not. So that means it is not a wall, or it is not 0, and the ways -1 and I +1, and the right cell is also not 0, so that means the right cell has a 1 or greater value, and the current cell is not 1, so it is 0 or pathable. So we say the ways -1 and I equal 1. Similarly, for the rightmost corner, so I'm going to use up most of this code. For j in range m-2, if not grid, j and -1, j +1 and -1. So we should use j and -1 to 1. Okay, so now for the matrix, for the number of different ways, we already filled the values on the bottom row and the rightmost column, and we can just simply start the iteration from here, and which just add up the number of different ways if the cell itself is not a wall. So I'm gonna use this for iterations again. And then, if not grid I and j, and, or that's everything. So if this is not a wall, then we can simply say the ways I and j equals ways I +1 and j, the bottom cell, plus the number of different ways for the I and the right cell, so j plus 1. And at the end, we are simply returning the ways 0 and 0 for this cell, the starting cell, as the number of different ways to the target. Let's test that out. Okay, so for one cell it is fine. Let's test different test cases. Okay, there we go. Another one. Let's submit that. Wrong answer. Let's see what is the test case. So this is the test case that you're failing. Let's test that out. Okay. So in this case, as you can see, this is a 2 by 2, and all of them are 0 except the target itself. But in our code, we haven't checked if the target itself is reachable, because regardless of the value of the target, we are saying that the value of 1 on the bottom right corner. So instead, let's say this is another edge case that you should consider. So if greet -1 and -1, so that means target is a wall, so you should return 0. Otherwise, we can continue the program. Let's try test that and then submit again. Oh, this time we have a runtime error. Submissions. List out of index. So we are starting from for this one should be from m-2 and n-2, since the first dimension is m and the second dimension is n. So I should use this way. Okay, there we go, 51 milliseconds, and apparently the problem is repeated again as a daily challenge. It was about 5 months ago, and it repeated again. But this was everything for today's problem.